Hello, this is question 12 on your November 2020 paper 1 from OCR MEI, the AS paper, and is a differentiation question. So we have part of the graph y equals x squared plus 1 over x squared is this one. The tangent to the curve at point 2, 17/4 meets the x-axis at A and the y-axis at B, or is the origin. So let's say that our point is here and the tangent meets the axis in those 2 points. So we have a point here and a point here. We need to find the area of triangle OAB, so this area here, which means we need this length and this length. So what we are going to do is to find the equation of the tangent at this point and the intersection with the axis, yeah? And that way we will have these distances. Equation of the tangent. First thing we are going to do is to differentiate the function to have the gradient. Yeah, and I'm going to rewrite this function as x squared plus x minus 2. Yeah, it's easier to differentiate. So the derivative of the first one is 2x, derivative of the second one is minus 2x to 1 less, so minus 3. When x is 2, because we are finding the tangent at that point, the gradient when x is 2 is going to be 2 times 2, just substituting here, minus 2 times 2 to the power of minus 3. Yeah, and substituting the 2 in the gradient. This is 4 minus 1 quarter, which is 15 quarters. So the equation of the line is y. I'm going to use this expression. It's the easiest with the information that I have. So I have y minus the y of the point, which is 17 quarters, equal to the gradient x minus the x of the point, which is 2. This is the equation of the line. So now we are going to find the intersection of this line with the x-axis and with the y-axis. With the x-axis, so to find point A, I'm going to do y equals 0 in that line, which means minus 17 quarters is going to be equal to 15 quarters x minus 2. I can cancel the quarters, and then I have minus 17 is 15x minus 30, which means x is 30 minus 17, 13 divided by 15. So this length here is 15, is 13 over 15. Yeah, we have one side of the triangle. We are going to find the other one, this one. So we are going to find the y-intercept of this line. We are going to find point B, just making x equals 0, the y-intercept. So I have y minus 17 quarters. I'm just substituting here x by 0 is going to be 15 quarters times 2. So 15 quarters times minus 2 is minus 15 halves. I'm going to write already minus 15 halves. And from here, y is going to be 17 quarters minus 15 halves, which is minus 13 quarters. Minus 13 quarters. That means that I draw it wrong, and because this y-intercept is negative, so actually the tangent is doing something like this. It doesn't matter. We don't even need to do the sketching. I did the sketch to help you. So the tangent is going to do, let's say, something like this. And the point A is the one that we just found, and point B is just below the x-axis. Yeah? But we are still using both distances, so it doesn't matter if it's positive or negative. So the area of the triangle is going to be 1/2 times base times height. So 13 over 15 times 13 over 4. 13 over 15 times 13 over 4. And this is 169 divided by 120. It says the exact area, so we are not going to divide the fraction. Yeah, That's the first part. For the second part, it says use calculus to prove that the complete curve has 2 minimum points and no maximum point. It says the complete curve because they have drawn only a bit of the curve, yeah, but we have to find the maximum or minimum, the maximums or minimums of that function. So what we are going to do is make the derivative equal to 0 and find them. So I'm going to do 2x, so the dy by dx equal to 0, and is 2x minus 2, and I'm going to write the x in the denominator because it's going to be easier to see how we can solve it, yeah? We are going to multiply everything by x cubed, so I have 2x to the power of 4 minus 2 equals 0, which means 2x to the power of 4 is going to be 2, which means x to the power of 4 is 1, therefore x is going to be plus or minus 1. These are the stationary points. To decide if there are maximum or minimum, remember we are going to differentiate again. Yeah, we differentiate again, and this is going to be 2 and minus. Again, I prefer to have the 2x to the power of minus 3 when I differentiate, so I have minus 3 times minus 2 is positive 6, x to the power of 1 less. Yeah. When x is positive 1, I have 2 plus 6 divided by 1, which is 8, greater than 0, so it's a minimum. When x is minus 1, my other stationary point, as my minus 1 goes to the power of 4, yeah, this is 6 divided by x to the power of 4, becomes positive, so again it's 2 plus 6, which is 8, is greater than 0, and is a minimum. So I have 2 minimums and nothing else, yeah, because I only have 2 stationary points. And that's all with this question.